Hello, we're going to work a problem with Avogadro's number this morning. Here's our chart that we use. It shows relationships between moles and several other quantities from the chapter that we're studying. First, we're going to look at number of atoms or molecules. These are related to moles by Avogadro's number, which is 6.02 times 10 to the 23rd atoms or molecules per 1 mole. We can also relate grams to moles through molar mass. Molar mass is the grams in 1 mole that you add up from the periodic table. Finally, we can relate the volume of a gas at standard temperature and pressure to moles using molar volume, which is 22.4 liters per 1 mole of any gas at STP. So this chart's very useful in looking at our problems. The first problem I'm going to work is how many grams are 6.85 times 10 to the 24th molecules of nitrogen gas. And again, we're given Avogadro's number is 1 mole is 6.02 times 10 to the 23rd particles. Let's look on our graph to see where we're starting and where we're going. We are given 6.85 times 10 to the 24th molecules of nitrogen gas. So we are starting here in this box. We are asked how many grams, which is this box. So this is going to be a two-step problem. We're going to have to go from our molecules first to moles. Then we can go from moles to grams. So this is going to be a two-step conversion problem. As always, we start with our given information, which is 6.85 times 10 to the 24th molecules of nitrogen gas. Do you notice an error? Hopefully you caught that nitrogen gas is in fact diatomic. So it's not N, it's actually N2, and that's going to be important in just a minute. So first we use Avogadro's number to convert to moles. Because molecules is what we're starting with, molecules needs to be on the bottom. And Avogadro's number tells us there are 6.02 times 10 to the 23rd molecules in 1 mole. 1 mole contains 6.02 times 10 to the 23rd molecules. Molecules will cancel out. Now we're left with moles of nitrogen. So we're going to grams, which requires a molar mass. For a molar mass, we need our periodic table. We can see on the table that 1 nitrogen is 14.01 grams in 1 mole. But nitrogen again is diatomic, so it's going to be 14.01 times 2, or 28.02 grams in 1 mole for the diatomic nitrogen molecule. Because 1 mole is on top, the 1 mole is going to be on bottom. And again, there are 28.02 grams of nitrogen gas in the 1 mole. Now the mole cancels and we are left with grams. So let's get our calculator ready. Make sure we punch in our numbers correctly using the exponent button. So 6.85 is 6.85 times 10 to the 24th is simply the EE button. And that brings up our exponent on our calculator. And now we simply punch in 24. Notice I did not punch in times 10. I'm going to do that again. 6.85 times 10 to the is all wrapped up in the EE button. And now I simply punch in the 24. And that is how to correctly enter a scientific notation number. Next, we are dividing by Avogadro's number. So, divided by 6.02. Again, use the EE button for times 10 to the 23rd. And then 28.02 is on top, so it's times 28.02. Divided by 1 doesn't change anything. We hit equals. and we get 318.83222259. So how many sig figs do we need? We started with 3. Avogadro's number has 3. Our molar mass had 4. The least is 3. So 318.8 rounds to 319. 319 grams, because the 8 rounds up, so 319 grams is our final answer. So again, we started with molecules, so molecules has to go on the bottom. That is Avogadro's number. 6.02 times 10 to the 23rd molecules in 1 mole. 1 mole's on top, so 1 mole has to be on the bottom. There are 28.02 grams of nitrogen gas in 1 mole. Molecules cancel, moles cancel. We're left with grams, which is what we were asked to find, so that's good. We need 3 sig figs, and our final answer is 319 grams. Stay tuned. We're going to try another several problems using that chart. Thank you.